Okay, so as discussed some time back, let's do a small change in the application. So I'm going to delete these comments, and I'm not going to set up to like text boxes data context to employee 2. I just want to show a single employee on the UI. So considering that we are clear with the data context concept, now I have only one employee object which I've created here, and I just wish to show that single employee object into the UI. And then in here we have a name which is bound with the text box name bound with name, and text box age property text is bound with age. And then we have a button click, on click of which we are just trying to show some employees, like the source and a target. Source is going to be the one which is providing data, and target is something which is showing the data as of now. So one more time we will run this, and we'll see same sort of behavior which we saw earlier. It should show me Mahesh and 40 initially, and then if I just go to change, or if I just click here, it shows Mahesh and Mahesh as source and target. If I change it to Nilesh, and if I click here again, you will find out I changed the target just now, but source also got automatically changed. But then you observed it some time back, doing this kind of a change, which means changing the source doesn't change the target at all, which means programmatically when I change employee's value, which is ultimately source value, it's not going to change the target value, that is my text box. So why it doesn't change in the first place? Who is at fault over here? And if I want that kind of a binding, that is if I do a change here, it should reflect in the UI as well. What changes I need to do? In order to understand that, what we have to understand is something called as logical tree versus visual tree. So I'll go to XAML here, and let's try to understand where exactly this text box exists. So you'll find out this text box hierarchically, it's a third level element, which means level 1 it's window, level 2 stack panel, and then this text box that we have. So let's consider only text box name as of now. So text box for me, logically, it is at the third level right now. So this is what is the hierarchy that I, as a developer, I have created. But then when it comes to when we run the application, then what is it that happens in this hierarchy is interesting thing to understand. So to do that, what I'm going to do is I'm going to put a breakpoint here in this button show.click, so that we can access the text box at runtime over here. So here I run again one more time, and then what I wish to do is make a small change here. Rather, even if I don't change anything here, it's absolutely okay. So if I click here on the button, now what I'm planning to do is I am planning to get the source data and get the target data. So we already know employee's name is holding Mahesh as in data. Let's try to find out how this text box looks like right now. So I'm going to hold a cursor here in text box, and then you will find there is this tool which is called as Wpf Visualizer tool, a tree visualizer. So if I click on this Wpf Tree Visualizer, it's going to show me where exactly this text box is at this moment when we run this application. So I'm going to click on this tree visualizer, and notice now here runtime in memory, it shows me where exactly my text box resides. So what we know already is we know window. So this is the first level that we know. It's the same level here. Below over here, it shows me the hierarchy or currently printed UI. So window 1, which is a root. Sometime back, window 1 had a stack panel. So stack panel was at a second level for us. But if you notice now, stack panel is not the second level. Rather, somehow we have a border over here. Inside the border, we have add-on decorator, another element. Inside that, I have content presenter, and inside that, I have a stack panel. Which means when we code or when we coded, stack panel was at the second level. And when we run, you will find out stack panel is at the 5th level. So there is something called as window, has a border, has an add-on decorator, has a content presenter, and that has a stack panel. So it's not second level, it's a 5th level control now. Then if I expand this, there's a text box, it seems to be. I'll select this text box. Here it shows me the selected area. Now text box actually has a border, the content presented called Mahesh. So it has a border, and that border has a grid. Grid has some sort of scroll content presenter, and that has got something called as text box view, which internally has got Mahesh as in value printed. Now so much of complex hierarchy is what you see. Why exactly we have text box has a border kind of a concept over here? Do you recall sometime back when we tried to change age value to a wrong value, there was a red border around the text box. So that border, I said we did not put it, but then Wpf tries to put up when some binding goes wrong. So that border is not something that we had put up because we created logical tree. Wpf had created visual tree then, and in a visual tree, this border which we have with the text box, that border's color was set up to something which is called as red. Now, why exactly Wpf tries to create such kind of a complex hierarchy? You will find out ultimately. You saw it some time back. Button had a text box, button can have another button, button can have a stack panel, button can have other elements as well. So in WPF, every element is or can be treated as container control, and then we can keep on putting some sort of other controls as in content to the container control. So you will find out the complex UI element creation is possible in WPF, and this hierarchy is something which is predefined. That is, text boxes, they come up with this hierarchy, or so-called window, it comes up with this kind of a hierarchy. And then just imagine, that is, just to present Mahesh as in text, what we have is, it's like 12th 13th level hierarchy is what it had to create in memory. Okay, now what is it that it has to do with this hierarchy which is called as visual tree? What this has got to do, that emp.name equal to xyz changes in the emp, but it doesn't reflect in the text box. So why this thing behaves in some other way? Because what we have observed, if I change something in the UI, it changes in the emp, but if I change something in the emp, it doesn't change in the UI at all. Why is this difference? Who creates that kind of a complex hierarchy? Who is responsible for creating such kind of a complex hierarchy? Ultimately, visual tree, which we saw just now, visual tree is created automatically based on top of the BAML that you have. So, and BAML understanding is not the core CLR's part. BAML understanding is WPF runtime's job. So ultimately your UI is managed by WPF runtime in this case. And then your data sources are typically managed by CLR. Though CLR has invoked, CLR is the first one, or CLR is the engine which starts your WPF application. You will find out that CLR is responsible for bringing in WPF runtime in picture, and that WPF just drives the UI right now for you. Okay, let's try to see this diagrammatically, like who brings who, and then how exactly this communication happens. And then you will automatically understand why some things are not working automatically over here. So let's see diagrammatically presentation of or understanding of who is managing the UI and who is managing the code.